We hear about context engineering all the time, but do you even know what context you're sending to your AI tools? Well, if not, this video is for you. We're going to dive into OpenCode's context engine, understand how context is actually built up for each message, even how caching works, and how you can actually build a better agent for your use case so you can get the most out of it, especially reducing the context you might not even care about. Well, let's just jump in straight away, understand what context is. All right, so on screen, I've just got my presentation on OpenCode's context deep dive. This is just a quick idea of how to think about context, but let's just jump straight into it. All right, so we're going to start off with how context is actually built up, and I kind of want you to think of this as a context sandwich. We're going to start with the first bread layer, which is a very thin one. It's just a provider identity. This just helps with some models to perform better or spoof around certain limitations. So this is very popular in the Anthropic ones, just for OpenCode. They just say you're a Claude. That's literally it. I want to move to the base prompt. So this is like the core instructions. So this is like your build and your plan agents. These are the core instructions that are actually followed, like how it should work, what is the behavior patterns it should do. That's the base prompt. This will also be where your custom agent prompt comes in, will fall under this base prompt. All right, then we're going to move to the environment. What is the environment? That is your full repository. So if I just run to the code quick, that would be everything you see here. This will be the repository, all these little files that will be sent up to the agent. So that's what I mean by environment. Custom rules, this is like if you got an agent.md or Claude MD, this gets pulled in. So this is just like the rules that are always pulled on for every agent that comes in. Then lastly, it's your tools. So that's your tools that you are defined. So whatever tools an agent has access to, that could be MCP, that could be the like read tools, list tools, you name it. That's also pulled in as context and how the agent should use it. And then lastly, the last layer of the bread sandwich is your message. And all of that is kind of sent to Anthropic or your model provider to consume. So hopefully you get the analogy with the bread, how it's biting into it. All right, one concept I actually want to go over with OpenCode quite a bit here is OpenCode is an opt-out, not an opt-in. So they provide you a lot of the functionality as default, because I think if they didn't, most people would never even know the functionality was there. So you actually have to opt out a lot of the functionality, which makes it a bit of a pain to understand all the context underneath. But we'll go through that in this video so you fully understand. So one thing you must know, tools are loaded by default. And you'll see here, we got about 6,000, tokens that are consumed. Some tools are between, 4 to 1,000 tokens, and we have to set it to false disable. Another thing that's very important, this is even if it's in your global configs, is if you've got agents.md or Claude MD or context MD, these are pulled in, okay? So just watch out for that. Sometimes you might not even have any agents.md or context MD in your local project, but in your global, it might be there and being pulled in. So very good to know. All right, so this is just some basic prompts. So because OpenCode, you can change your model provider. So what do I mean by that? So if we just run OpenCode right now, what I mean by these model prompts is when we go models here, we can choose like Gemini or Anthropic or any other one. And each of these actually has its own prompt in OpenCode that it defaults to. And what I do find interesting is the default fallback prompt for any model that isn't listed on here is the Quen model. So that's very interesting. Also, another reason why I probably allocate to make your own custom agent so you can use your own custom prompt. So these are the default base prompts, and this gets pulled in for each one. All right, I want to talk about one thing called caching. I know I'm jumping quite ahead here, but how you must think about caching is when you actually send a message. So let's just go to, so say you are, you're in your context window here. So just imagine you in your context window here, you're sending your system prompt and user message. So on the first initial prompt response, this is all consumed as like tokens. So this is a factor of 1 price. So essentially, this is all gets consumed at 1x. Okay. But we know the system prompt doesn't want to change for the next type of a message. Is there a way we can reduce this cost because this is not going to change? We probably know the initial message isn't going to change either. So when we get a response to the AI, will come back with AI response here, and it will then also have a user message. Well, you might want to respond to the AI response and have another to initiate another response to the server. But we've already sent these two. We already sent these two messages across. Is there not some way we can reduce this cost so we don't have to send everything again? Is there any way we can reduce the cost so we don't have to send all this again? So to another one, we can pay again another 1x cost. And as our sequence goes, it gets more expensive and expensive. This is actually where caching comes in. So what actually happens is instead of the second response being we send everything, this bit here is actually a cache. So this actually goes to its own little cache one, which actually gets charged at about 0.1x. So it's 10% the cost of a normal prompt, and that's what caching really is. You don't need to worry too much about this, but I thought it was kind of interesting to know what's actually happening under the hood. So every sequential prompt will get the caching, so it just reduces our cost. And certain providers provide this, from the get-go, but we'll go into that in a bit more detail. So this is caching, just quickly. All right. So this is kind of what I'm talking about here. The first prompt, say if you've got 9,300 tokens, its full price is 28. But then the second one, we understand the 9,000 is price cash, so it's 10% the price, and then it's adding the 322 new context, so that the price comes down dramatically. So we kind of saving quite a bit of costs, and then it kind of carries on. That's mainly what I'm talking about here. So just go through an example. So say we got the base prompt, the evaluation tools. So the request is made, and we're saying, okay, we're going to definitely cache this because, well, we know it's not going to change. And when the request comes back, we kind of want to cache everything that came back. So it will hit the cache according to what's sent through. It will only send these two new messages as the tokens to process. And you'll see on the next one, those will then be added to the cache for the next one to reduce the cost. And cache lifetime is about 5 minutes. And then after 5 minutes, it kind of falls away. And every cache hit actually resets the time. So that's another thing to know. And I'm just going through Anthropic here. The cache reads are 10% import price, which is really handy. So it really reduces the. All right. So where this becomes a problem is for local models. Local models don't have cache. So for a typical OLAMA setup, you had AK context, for example. The whole context is used. There's no caching mechanism. So just note, this doesn't apply to open source models at all. And open source model, you really have to also think about context overflow. So you really have to constrain your context. So really understanding how to limit context going to open source models is super important. Anyway, I kind of want to break down some of the tokens that OpenCode sends through. So before I go into this, what am I actually talking about? So let's just jump to this. I'm just going to say hi, and we'll get a response back. You can see, hey, I'm OpenCode here to help you, etc., etc. But we can see at the top here, we're only 11,400 tokens in. Okay, what's actually going on here? So I'm actually going to just do an export here, so I can get the session ID. So you can see here, I've got the session ID. Now if I open that, we can literally just see what the response is. And to make this even a little better, I've got this nice little script I'm going to run to get a lot more details about this little session. So I'm going to just run this and make this a bit bigger so we can kind of dive in what's going on. Okay, so we can see we're using the build agent. It's called Sonnet 4.5 and the provider's Anthropic. And we can see the input tokens was 3 because we literally said hi. Output tokens was 73, but we can see there was a cache write of 11,330. But where did this cache write come from, you might ask? Well, that's what we're going to find out. So one thing you'll see is a lot of it is just, we've got the header here, your Claude. That's that top of the bread I was talking about. We've got our base prompt. and it's about 1,736 tokens in OpenCode at the moment. And it got our environmental context, our custom instructions. There was no custom instructions, so nothing was found. But we can see there was a lot of tool calls that were pushed through. That was about 6,606 tokens. But we can also tell from this, these were cached because, well, they're not really changing. So OpenCode's clever enough to state that, hey, these codes don't really change that much, or this tokens don't really change too much on the default tools, so we're going to cache them. And that's literally what happened. So we can see here, this is where the whole fund comes from. So the estimated tokens for the system is about 836. And we kind of estimating what's going to happen here. So our system context was, 11,300 cache, your message, and the AI response. So yeah, so we can kind of see what happened here through this prompt. Hopefully that makes a bit more sense. So this is kind of what we talk about. I'm trying to break down how these tools, they kind of represent that 6,600. So we know the most expensive tools are like Bash, to do, to write. That's like, if you're using OpenCode, that's that one that actually, it's like the to-do list and multi-edit things. And essential tools, like, which are quite low, we can keep a read. I think this is actually not off or right. Yeah, so when I use read, it's a bit more. I think list is, if you do ls, it's 264, not read, then write, edit, grep. All right, so I'm just gonna jump in back here. I'm actually gonna delete this, and I'm actually gonna show you guys some way that we can try reduce all our tools as much as possible. So just again, let's just go over this once more. So if I say hi to the build agent, we'll look at the tokens. The tokens is 11,412. But I actually want to show you a different agent that I've made, and I'm going to call this small. And this should give us a lot more. I'm still using Anthropic here. We'll change the model in a bit, but I'm literally going to say the same thing, hi, and we'll see how many tokens I get. And you can see it's a huge, drastic improvement. I'm going to get 206. We went from 11,100 to 206. But I am sacrificing a lot here. I am sacrificing a lot of those tool calls that give it that agentic workflow experience. Now this is just a basic, very basic ChatGPT that I could interact with. So that's one way. Then I have another one, another agent that I want to show, which is called near zero. I'm just going to do the same thing, 206 at the moment. Okay. So we can see the near zero and the small are the same right now. Let's have a quick look at what each one is. So if we go to the small, we can see, hey, always respond with hi, nothing else. This is literally my system prompt. So this is actually eating a lot of my tokens. And we can see the tool calls, we're literally saying, hey, reject all tool calls. All right. So that's how it's actually getting to that 200. The near zero, this is the one I actually want to experiment with you guys so you can see how you can up it. So I couldn't find a way to disable all tools like in a good manner that would work 100%. For some reason, it was still pulling in context for tools even when it was disabled, so there was a slight bug. But I did find a workaround, and that's what I'm going to show you here. So at the moment, you can see we've got this all at the moment, but I can actually enable certain. So if we go the read here, we do true. This is the important one. Exit this, and we go back. And this is for the near zero. We'll just tab to it. And we can see it's got this read tool, so I can read that and pull into this. Take the same command, copy it. We can see it's read everything. All right, so let's just open a new one here. I'm just gonna, I want to open a new OpenCode so we can run our small and type the same command to see if it works. And we can see it only replied with hi. But let's just see if this, if we change this, help the user, and we will exit and do it again. So we can see it's trying to do something here, but it doesn't really, can't really get there. So it's used 700 tokens, but it doesn't really understand how to do it. So it understands it needs to read the file, but it's not really reading tools to do it. Because we disabled everything. So we did 700 and we'll, so you can see this one read through, kind of got all the details. Great. All right, so the best way to do all of this is, again, always start with like the false. This is mainly if you just want to reduce all the tool calls, and then incrementally add the true underneath to add them back. That's what seems to be working for me right now. I don't know if this will always be the case, but I found this very useful, especially if you want to build open source models and you really want to reduce your context window. 11,000 just doesn't seem the best use for some of these models, even though the default prompt does disable a lot of them. It's always nice to understand how you can optimize your own AI agents for what tool calls and the context, because context engineering is super important. Anyway, so this was just a quick video on how context works under the hood for OpenCode. This does kind of apply to Claude Code and other things. I think the opt-in, opt-out method will be different depending on which AI tooling you use, but the concepts kind of stay the same. And if you are interested in making your own models or contributing to an open source community, I've actually got my own repo called OpenAgents that I'm working on at the moment. I'm doing a bigger update at the moment so we can actually store different prompts for different models or different agents and actually test the scenarios with different evals to get the right responses. I'll leave that on the link down below. Please have a look if you feel interested. But thank you so much for watching, and I'll see you in the next video.